Alright, here is my video for assignment 2. I'm gonna race and jump right into this code here. So here we go, we see the prompts for the information that we need to enter in order to set up the game. So what we get here is we get a layout of the board and then a move set underneath it, and we will see why we need that in a second here. So I'll just implement 2 moves here really quickly. Cool. Alright, so what's happening here is the board itself doesn't actually implement images of the lines going from dot to dot. That wasn't something I was able to get in time, so the move list underneath here is to kind of provide what that does visually. So what you see here is I made an initial move from position 0 to 1, and so that gets reflected here in the list item for position 0. So H corresponds to lateral move, V to vertical move. And so those get updated once that X is kind of placed there and that move is made, can't be made again. And there's some safeguards in the code for that. So basically you just go back and forth like this, and then once a score space is claimed, that actually does get reflected on the board itself to show either U for user or CPU for AI. So I will now, that is about the gist of that I wanted to demonstrate. So now I will jump into the code. So I will jump straight into the CPU turn handler. So this is where all the stuff from class that we've been working on is implemented. So what we get here is we start with, as soon as it does all the initial prompt and the printing of the board, we get a create start function. And what that does is take the current state of the board and create a node for it. And then that node is placed in a list that then gets iterated via a successor function that creates the successor nodes for it. So the node here, so the nodes, what the information that it stores is the parent, children, score, depth, all of that stuff that it needs, and the state as well. And so then what we do here with the get successors is that we actually take that start node and we actually then begin building out the tree of the moves based on the starting position and then also the apply that was specified. So that all gets implemented down here, right here. So get successors, a little bit further. Yeah, so get successors calls a vertical successors and a lateral successors function. And those just put onto the queue all of the possible moves that could be made vertically and then laterally given that initial board state. And so what happens from there is that it gets scored. Once it kind of generates down to the specified ply and we get those leaf nodes added to the front of the queue, we then want to evaluate those leaf nodes, which happens here. So the way that happens is that while the depth of a given set of nodes is equal to the ply, that correlates to the leaf nodes, we want to generate scores for those and set those in the node slot for it. So then that all happens here. Basically it calls a check scoreboard, which kind of iterates through the board and then kind of simulates moves made, boxes claimed, all of that. And then it returns that board, and then that gets put into the generate score function, which then basically goes through that board again, tallies up all the scores, and then does the heuristic act of subtracting the user score from the computer score. And then from there, what happens is that it takes those nodes, or it takes that queue now, and starting with those nodes, we do some mini-max work. And basically the way that is going to work is that we'll use find min as an example. It basically starts with those leaf nodes for a given parent. It will iterate through those nodes. It will keep track via beta value here, but then also what it's pushing up to that parent node. it will then generate the min score, in this case, for all the nodes under that given parent. And then once we get to a new parent, it basically then resets all of that initial information to then run again through those nodes. And so it keeps backing up all the way to the root node. So that root node contains the score that will then correlate to the node that's going to actually be used then for its next move, that contains the state for the next move. So what that does down here then is when we get to count 1, because what this is doing is it's kind of switching between min and max to get to that state. And so then when we get to count 1, which contains those initial moves that are going to be available, it then tries to find the score that matches the root score, and then that's going to be the node. So that is it. Hope you enjoy that short and sweet kind of walkthrough of my code.